Good morning, students. Today we shall discuss double slider crank chain. In previous classes we had discussed single slider crank chain. So today we shall discuss double slider crank chain. So 4-bar chain having two turning and two sliding pairs such that two pairs of the same kind are adjacent is known as double slider crank chain. So here in this mechanism or in this chain there will be two turning pairs and two sliding pairs. So this mechanism have three types of inversions. So first inversion is elliptical trammel and second one is Scotch yoke mechanism and the last one is old Amps coupling. We shall see the different inversions in detail. So how does this work and what it is. So first we shall see the elliptical trammel. This is an instrument for drawing ellipses. As the name itself suggests, this is an instrument used to draw ellipse. Here the slotted link is fixed. Here you can see that there are four links and the link 1 and link 3 are sliding pairs and link 2 is turning pair. And link 4 you can see that the link 4 it is a frame, it is fixed, and link 1 and link 3 can slide inside the frame. There is a link to it is a link to long rod attached to link 1 and 3 and the end of the rod is point R and it will trace the ellipse. The sliding block P and Q in vertical and horizontal slots respectively, so it can slide in horizontal and vertical slots. The end generated is an ellipse and the displacement of sliders P and Q. So the coordinates of point R are X and Y. The vertical distance is Y and the horizontal distance from the mean position is X. So from the figure there is an angle theta represented there, you can see that. So from figure cos theta is given by adjacent by hypotenuse. So the adjacent side is X and the hypotenuse side is PR. You can see that the vertical slide or hypotenuse side is PR, and for sin theta it is opposite by hypotenuse. So the sin theta is y by QR. You can see that y by QR. So we shall call this as equation 1 and 2. Let us add square and add equations 1 and 2. So what happens when we square and add? So it becomes x by PR whole square plus y by QR whole square is equal to cos square theta plus sin square theta. Here I have given cos theta whole square, so that is nothing but it is cos square theta. So from trigonometry or from basics of mathematics, you might have known that the sum of cos square theta and sin square theta is equal to 1. So the equation x square by pr square plus y square by qr square is equal to 1. So this is the basic equation for ellipse, and hence the link to pr it will trace an ellipse. So if the equation is that of ellipse, here the instrument traces an ellipse. So if r is midpoint of pq, so now the point r is outside pq. If it was inside pq and if it was midpoint of pq, then the part traced by the midpoint of pq would be a circle. So in that case pr is equal to qr. So if point r is midpoint, then pr should be equal to pq. No, it is qr they have written here. It's an equation of circle with pr equals qr. So it's an equation of circle with pr is equal to qr. So that will be the radius of the circle. Now we shall see the next inversion, that is Scotch yoke mechanism. So in this mechanism you can see that the link 1 is fixed, link 2, link 3 and link 4 all are moving and only the link 1 is fixed. So when PQ rotates about point P, PQ is the link 2, when it is rotating or moving about point P, the slider 3 and link 4 it will also move. The slider Q reciprocates in the vertical slot, so along with that the frame 4 also moves along with that. So the mechanism is used to convert rotary to reciprocating motions or mechanisms. So here in this mechanism you can use this to convert rotary motion to rotating or reciprocating mechanism. So the figure you can see here. So the next last inversion is the Oldham's coupling. It is obtained by fixing link 2 connecting the two blocks P and Q. You can see from the figure the link 2 is fixed. This link 2 it connects slider 1 and slider 3 or links P and Q. So here if one block is turning through an angle, the frame and the other block will also turn through the same angle. Here if since the link 2 is fixed, if one block is rotating, if either slider 1 or slider 3 is rotating, then the other slider and the link 4 also rotates with the same angle. So this is an example of third inversion and Oldham's coupling. You can see in the figure. Thank you guys.